Excellent. Hey, welcome to FRQ 5 of 2016. You have made it this far. And this is the one that you peek in your little AP booklet and you see it and like it makes your skin crawl a little bit because you start to freak out. But actually, this one's pretty straightforward. Like, there's only 3 questions to it, and some of them are just really straightforward. You have to look at it and understand. They're gonna ask me about the volume of this shape, right? They're gonna ask me to find the volume of this. It's a disc, not a washer. There's nothing missing in the middle. And they're also gonna ask me something to do with dr, dt, dh, dt. So I know I'm gonna be doing some type of like implicit differentiation where I'm going to have those values and I'm going to plug them in. That's it. So as a matter of fact, this one actually turns out pretty easy. So I'm going to jump to our points page just so that we have what we're looking at. So here it is. And it gives us some pretty key pieces of information. So for example, it says that this funnel, the whole funnel height is 10, so I'm going to go all the way from 0 to 10. So as this thing fills up with liquid, this height gets higher and higher and higher. At first the height's going to go really fast, and then the height's going to slow down. So the radius is going to also go from 0 to whatever the radius is. It's not really clear. It's not really given in the problem, and I don't need to know it. So it gives me a function for r related to h. So this is r related to h. So that is the relationship between these two things. So you could think of it as an x and y axis, where h is the y axis and r is the x axis. And it says, hey, find the average value of the radius of this funnel. Well, the average value function, if you remember, was 1 over b minus a times the integral from a to b of whatever function we're talking about. So if this is my radius function, then I need to find the integral from a to b and then multiply it by 1 over b minus a. Well, here are my values that I'm talking about. It starts from 0 and goes to 10. So it's going to go from 0 to 10, and this is going to be a 10 minus 0. So let's look at their solution down below. Yes, the numbers are gross. This problem is about your numbers and your positives and negative signs and whether you square everything and all that stuff. So here it is, 1/10, just like we talked about, from 0 to 10 of the function as it was written, dh. So they went ahead, put the 120 out in front, gave it 1 over 200, they moved it over here. And then they took the integral of 3, which was 3h, and the integral of h squared, which was h cubed over 3. And they're going from 10 to 0. So they plug in a 10. You don't have to worry about the 0. It's nothing. So they plugged in a 10. And they got 109 over 60 inches. So you get a point. A point if you wrote the integral. You get a point if you got the correct antiderivative. And you get a point if you got the answer. All right, cool. Question B says, find the volume of this funnel. Yes, I'm finding the volume of this funnel. Well, those are a bunch of disks. So remember, the area of each disk is pi r squared. And I'm going to add up all of the disks in this thing from 0 all the way to 10 in the direction of h. And since r is worth this, that's going to be my value for the radius. So this is what I'm going to be able to use in my integral. So remember, my integral is going to be pi r squared. So here it is. Volume equals pi r squared. And that's the r. Remember, the r was the function they gave me. And since everything's in terms of h, I'm going from 0 to 10. So the first thing I would want to do is square this stuff out. So I square the 20, that gets me the 400. And then I square 3 minus h squared. I FOIL that out. Then I have to integrate that. That is kind of gross. I know, it's disgusting. However, these are just 10s. You're just going to plug in 10s. So you plug in a 10, it makes it 90. You plug in a 10, it makes it 2,000. And you plug in a 10, and it makes it, what, 100,000 divided by 5, which is just 20,000? Sound right? Sounds right. All right, and then we simplify. Add them all together. You could probably simplify this first, add it together with that, divide by 400, and you get this. So once again, a point for the integral, that's this guy, a point for the antiderivative, whoops, sorry, point for the antiderivative, that's not it, a point for just the answer. Okay, last question. So this is the one that people don't like because it's kind of gross. It says, if this funnel contains a liquid that is draining from the bottom, at the instant when the height is 3, so at 3 inches, the radius of the surface liquid is decreasing at a rate of 1/5. So d, the radius, dr dt is 1/5. At this point, what is the rate of change of the height? I'm going to find dh dt. So this shouldn't be that bad. I mean, I have the equation right there. So I'm going to have to take this equation and find the derivative of it with respect to time. So remember, if your equation is r equals 1/20, 3 plus h squared, then I'm going to find d dt of this side, and I'm going to find d dt of this side. So when I find d dt of this side, it just turns into dr dt. And here I get the 1/20th out in front, and the derivative of 3 plus h squared is just 2h. That's it, dh dt. And I know what h is. They told me h was 3. I know what dr dt is. They told me that was 1/5. Oh, look at that. It's decreasing at a rate. So it's a negative 1/5. So make sure you underline words like decreasing and increasing. Don't do what I did. All right, so negative 1/5, and then I solve for dh dt. So 2, you get, it says chain rule. Oh, I guess the chain rule is the dh dt part and the dr dt part. That's odd. And then, of course, the answer, which is going to be negative 2/3. Not too bad.